We will be hearing from Andrey Ignatov.
Hi, thanks for joining. My name is Andrey Ignatov, and I'm a software engineer at Facebook, working on containers and occasionally on Linux kernel. My talk is about cgroup-bpf usage in twagent. Twagent is a daemon that runs on every Facebook server and manages containers, or as we call them, tasks. Every task consists of usual building blocks like cgroups, namespaces, images, etc. Our fleet is on cgroup v2, what allows us to use cgroup-bpf. Cgroup-bpf is a way to attach bpf programs to cgroup of a container so that it will be run only for objects inside this container. For example, for all sockets. twagent has many features implemented in cgroup-bpf. I'll describe a few of them just to give a better idea what can be done. Our DC network is IPv6 only. Every server has /64 prefix, and we want to assign IP addresses from this prefix to our tasks. At the same time, many services don't need full L2 isolation and simply want a separate IP address. We handled it with a few cgroup-bpf programs. Server part is handled by bind program, so that, for example, wildcard path to bind sysctl by TCP server will be overridden by task IP. Client side is handled by connect and sendMessage programs, so that outgoing TCP and UDP traffic goes from task IP instead of an IP chosen by kernel. Some applications try to connect to other applications in same task using : :1. We handle it by tracking all listening sockets in a task by TCP-bpf program that tracks TCP listen and TCP close states. And when a connect to : :1 happens, we know if we need to override destination with task IP. This scheme works with the use port, fast open, and has close to zero overhead. Next example is transparent TCP proxy that redirects outgoing TCP traffic of a task to a proxy and lets the proxy know the real destination to connect to. The main use case is transparent TLS for a long tail of services that don't support encryption natively. Again, we do it with a few cgroup-bpf programs. On connect sysctl, we run a program to save original destination in a bpf map and set the proxy IP port as the new destination. Socket cookie is used as the key. Next, we run TCP-bpf program on connect callback right before sending SYN. This program finds previously saved entry in the map by socket cookie and replaces it by a new entry with source IP port known at this time as the key and original destination as the value. Now the proxy can accept the connection and find original destination for it using the bpf map and source IP port of the connection as the key. Garbage collection happens on TCP close in the same TCP-bpf program. Or it can be done with socket local storage. The link at the bottom of the page describes the proxy logic. And the final feature I'd like to describe is our container firewall. It's two cgroup-bpf programs, ingress and egress, attached to a container. It can dissect a packet and either drop, lock, or pass it with some probability. If use case allows, we can replace per packet programs by per socket ones. For example, connect and sendMessage hooks can handle outgoing TCP and UDP traffic. The firewall can be attached either on task start or on daemon at any given time, and the latter is used for network faults injection. The firewall is integrated with our service discovery system so that a service with many endpoints can be described by just one rule. There are many more cgroup-bpf features implemented in twagent, mostly networking, but not only. But I'd like to finish with a few words about our cgroup-bpf infra. libbpf is the only library we use. It naturally aligns with our C++ infra. We enable BTF everywhere. We heavily test all our programs, including multi-kernel VM tests in Chemo, what caught many bugs both in kernel and in our applications. And finally, we monitor CPU and memory usage of all our programs and maps across the fleet using a tool named bpf tags. This is all I have for a 5-minute talk. Thank you.
Thank you very much, Andrey. Give a round of applause. This was our last lightning talk for today.